All right, but we are on lesson 6 of unit 3. There's only 9 lessons total, so we're really toward the end. This time next week will be the review day, and then that Wednesday next week will be your unit 3 test. So really no time for you to fall behind. All the practices have been like under 5 problems. I can tell you today's is like 4 problems. So really like just get it done. That tells you usually how you'll do on the test. Your quizzes from yesterday are viewable, so you can do corrections from home on quizzes, but you don't have to come in tutoring for that. If you need extra help, like please ask, either come to tutoring, and it doesn't have to be my tutoring that you go to. Like between the algebra teachers, we have tutoring every Tuesday, Wednesday, Thursday. Mine is just on Wednesday. So keep that in mind. But today we're talking about what's called residuals. So first, you're going to mentally calculate how close the estimate is to the actual value using the difference. What does difference mean in math? Arlie? Subtraction. So as you can see, they're doing the actual value minus the estimated value. And order does matter in subtraction. So we're going to subtract. You guys right now in your head, so don't say the answer out loud, try to answer this next question. How would the answers to these 2 questions be different? The one where the actual value is 21 cars and the estimated value is 20 cars. And the other where the actual value is 20 cars and the estimated value is 21 cars. So again, you don't say it out loud. Just put your thumb up when you think you know how those 2 answers would be different. So when you think you know how those 2 answers would be different, when you do actual minus estimated, you just put your thumb up. All right, I'm not seeing any thumbs. Am I just like missing them somewhere? Okay, Joshua, how are the answers to these 2 questions different? One's positive and one's negative. So let's see, if we're doing actual minus estimated in each situation, over here it would be 21 minus 20. What do we get? 1. And then down here, 20 minus 21 is -1. So that's how they're different. So we don't just want to know the difference between them. It has to be whatever the actual was minus the estimated. So I know like a lot of you will just want it to be the bigger number minus the smaller number. It's really important that you just do whatever the actual is minus whatever the estimated is. Okay, now this formula is really important because that's actually how you find residuals. So in your math talk section of your notes, you don't have to really do like this scratch work or anything, but definitely write down the key points. So like when I say residuals equals actual value minus estimated value, you need that, especially like for your homework, for example. You need that for later. Now, actual values are what you see, for example, like with your actual eyes. Like if you were doing an experiment or doing a survey, that would be like the raw data that you collected. So maybe make a note of that. So actual data would be like raw data. So what you observed or what someone observed. And then we have estimated values come from your linear models, trend lines, whatever you want to call it. So estimated values, you could write come from basically y equals mx plus b. We have a bunch of names for it: linear model, linear regression, trend line, line of best fit, all mean the same thing, but they're all going to be in the form y equals mx plus b. So it's what you get from putting it in that equation is your estimated values. All right, so questions on those definitions. All right, so then let's do a couple more of our actual minus estimated. So here's another one. Again, preferably do this in your head. It helps you be more fluent. Would I ever tell you to do math in your head any other time? No. Like on a test, I would do this with a calculator. But for right now, calculate the actual minus estimated just in your head. When you think you have the answer, pick your thumb up. So it's actual is 24.8 grams, estimated 19.6. And you know the answer. I feel like a lot of you are just not trying. Like it's subtraction. What's 24.8 minus 19.6? Harley, what'd you get? 5.2. Anyone disagree with that? All right, feel free to check it in your calculator. We usually do these in our heads and math talks, but in real life, please check it with your calculator. Let's do one more. Let's do this one down here. So we don't need to do all of them, but let's do the one that I started. So when the actual value is 41.5 and the estimated is 45.9, what's going to be my residual, the actual minus the estimated? All right, Louis, what'd you get? 1.4? Oh, 4.4, positive? Okay, so I have the actual that is smaller than my estimated. So then my answer be a negative 4.4 is correct. But yeah, so are we seeing the point here? So actual minus estimated. The math itself is not hard. You just need to remember residuals are my actual minus my estimated. Do they always tell you this is actual and this is estimated? No, but actual comes from like the raw data. Estimated comes from the linear model. Questions on that? All right, so then let me bring you back to that oranges video that we watched the other day, where you had to like see the weight of the oranges as each one was added. We're going to use that data and use technology to find the line of best fit. And then you're going to write it down on your paper. So you don't have to take out your notes from 3.04. The data is right here. So using this data and using technology, because it's quicker, find the line of best fit. I know a lot of you probably need to get your Chromebooks going or Desmos on your phone. So I'll give you a little bit extra time, but no more than 4 minutes. All right, so have a line of best fit ready in 4 minutes. And if you don't know how to use your technology during the 4 minutes is when you should ask. Can you tell me what you wrote for your equation? So it should be in the form y equals mx plus b. So you got y equals number 4. Okay. Did anyone get something different than that? No one else. You all got that, or you all got nothing? Okay. So then no one wants to speak up. All right. We will see if that's right then. Since so many of you are not speaking up, that means you're not confident in your answer. So make sure as I'm doing this that you're either taking notes on the steps for how to do it or practicing it like with muscle memory, doing it yourself too. But this is like one of those things that like the computer does it for you. All you got to do is enter a few things that are given to you. So Desmos is the one that everyone will have access to on our unit test, not for state testing, but you know, at least everyone will have this one. How do I put a table in here? What do I press? This plus, add item, and I'm adding a table. And then from there, you're just copying what your data was. And for this part, you especially don't want to do any rounding early. Like just copy the data exactly how it is. If we need to round at the end, then we can, but you also don't want to like flip-flop any coordinates. You don't want to just leave some of them off. I mean, your answer will probably be about the same, but we want a line of best fit. So I have a table, I have a scatter plot. How do I make it put the line of best fit on there? What do I do now? All right, table 3, someone over there. This part should be quick. Like, we're not even like to the meat and bones of this lesson. So Dinah's kind of helping out. Put the code. Put what code? Like, what buttons do I press? Talk to me like I'm like really dumb. What do I press on my keyboard? Perfect. That is it. You don't have to do any special formatting except for maybe know where the squiggly thing is on your keyboard. For me, it's top left. So like shift, hold down that button. There you go. The Y1 will automatically format to a subscript. You literally just press Y and then the number 1. All right, now it gives you some great stuff here. As you can see, it drew the line of best fit through the middle of the data where the points seem to be clustered around. The computer will always give you the best line of fit. All right, and there's lots of stuff here. Some of it we're going to use today that is new to you. But for just making your linear model, you need this. All right, so 1/4 is equivalent to 0.25. So it is close to what our actual slope is, but let's use those decimals. And earlier I had someone give me like that whole long decimal. I think rounding to 3 places, since our actual data is rounded to 3 places, I think 3 places would be enough. So for my slope, is it gonna be 215 or 216 based on my rounding rules? Sorry if you can't see, hopefully you can put it on your screen and see it better, but. Is it gonna be 0.215 or 0.216? 0.216, good. So the number to the right of the 5 is 8, so you have to round up. And then for my y-intercept, my v, gonna be 0.345 or 6. 5. All right, that's my linear model. Sometimes the question is really nice and we'll just give it to you. Others will give you the data and then you just go through the process. But regardless, like, it's not that hard. It's not like I'm making you like memorize quadratic formula right now. You just have to memorize how to press the button. Okay, so there we go. The next thing, our actual data is what's in the table. It even says actual right here. We're gonna fill in this column that says linear estimate. So our estimate is coming from our linear model. So at least show some scratch work, but I will tell you, we're gonna add a residuals column. So leave enough room to still have a residuals column on your table later. But to figure out our estimated values, first know the difference, like what would be X and what would be Y. X is always like your independent value. Y is always your dependent value. So the weight of the box depends on how many oranges are in it. To get my estimate, I'm going to plug in each of these X's. So here's like some scratch work you should write down so that you can see where we're getting these numbers from later. But we're doing 0.216 times X. My first X is 3 plus 0.345. So plus 0.345. Anytime you plug stuff in, what do I tell you to use? So anytime I tell you guys to plug stuff in, what do I tell you to use? What did I use? What did I use when I plugged stuff in? What are those things called? Parentheses, thank you. And that makes my life super easy in Desmos when I do that. Because then when I put in all my other values, all I have to do is change what's in here. Okay, so my first estimated value when I plug in 3 into my linear model is 0.993. You're going to put that here in the table. If I want to find my estimated when X is 4, all I have to do now is change that to 4. And so on. So I gave you 2 of them. Fill in the rest. We will assign a reporter and it'll be like a lightning round because you should already have them by the time I call on you. Okay, so do that. Get all your estimated values for your table. So table 8, what about when the X is 5? What's my estimate? Like 530? Oh, yeah. Okay. Let me just verify because I don't have my key in front of me. All you have to do is change that to 5. Did you round differently, maybe? I'm writing okay, so not a big deal, but let's make sure it's this now. So 1.425 is what everyone should have for when it's 5. Table 9, what about when it's 6? What's the estimated value? 1.6. Okay, good. Table 1, what about when it's 7 for the x? Yeah.
148.57.
Okay, good. Table 2, when it's 8, what's my estimated? Okay, good, 2.073. Table 3, what about when it's 9 oranges? And table 4, when it's 10 oranges.
2.5.
All right, so any questions on that process? So linear model, the equation, and y equals mx plus b is what we plug that into. Now you're going to calculate residuals. So add a residuals column to your table. What's the formula for residuals? If you don't know the formula for residuals, then you need to like star it, highlight it, put it at the top of your paper. But residuals is actual minus estimated. And look, your table even uses that verbiage. They don't use it all the time. But you just need to take your actual, which is 1.027 for the first one, minus your estimated, which we got from the linear model, so minus 0.993. And my first residual is 0.034. Now do that for the rest of them, and it'll be lightning round again. Because again, it's just subtraction. So that's all residuals are, it's actual minus estimated. Think about it like the alphabet, A comes before E always. So always do your actual minus your estimated. I'll give you another 90 seconds for this one subtraction. And you can use a calculator. It's 4. .03 like that. I'm not hearing it right. Okay. Gotcha. So if anyone disagrees at any point, please just let us know. Otherwise, like, I don't feel like I need to check every single one of them, but if you disagree, please, we can stop and do that one. So now whoever spoke for your group last, table 6, and I'm gonna okay, we'll finish with it. Table 6, what's my next residual? All right, table 7, what's my next residual? When it's an x of 6. Was that a 2, 4 or a 2, 3? Now whoever spoke for your group last, rotate one to the left. Table 8, when the x is 7, what's my residual? Table 9, when my x is 8, what's my residual? Okay. Table 1, when my x is 9, what's my residual? And table 2, when x is 10, what's my residual? All right, anyone have any disagreement? Now, on your notes, it has space for us to plot it by hand. I feel like that's a less essential skill. I'll just show you how to look at it in Desmos, so that sounds fine with you. Okay, you could sketch it by hand if you want, but these residuals tell me how good my line of fit is. And granted, the computer will always give you the best one. It'll always do it through the middle of the data where the points seem to be clustered around it. In Desmos, you could also look at the residual plot. So you see here, when we typed in the code, it gives us like a bunch of stuff. So far, we've only learned like slope and y-intercept there. We will use all of this eventually. But residuals, that's the name of today's lesson. If you press this button that says plot, and you can even do it on your screen, you get what we call a residual plot. It also adds a residual column to our table. Let's go back up to that. If I can. Okay, you see? And granted, they have way more decimal spots than we do, but isn't this like what we got for our residuals? Okay, so that's how they actually got them. They did the actual minus the estimated. But this is our residual plot, what's in the blue. The closer that it is to the x-axis, the better the fit for the data. So would you say that this is a good fit for the data? Are all these dots pretty close to the x-axis? All right, so think about why that is. Because when we calculated it, it was actual minus estimated. What would be the best residual value that's on our table? So out of all these residuals, which one do you think is the best one? Where our actual was really close to the estimate? All right, you'll answer that in your groups. So number 5, if you go on the back, which point on the scatter plot has the residual closest to 0? And what does that mean? Also, under number 6, you have space to summarize how to make a linear model, how to make a residual plot with technology. Because remember, on a test, I can't help you with that. So figure out what the best residual would be based on what I told you. And take time to write down what you would need to write in Desmos. It's on the back of your notes. If you finish early, do the cool down, because that's basically the test question that you'll be asked is what the cool down is. Table 2, can you tell me what's the best residual? Out of our list of residuals, we're going to write the best one. And why is this one the best one? Okay, good. So this kind of answers number 5. This is the residual that's closest to 0. So residuals closest to 0 or 0 exactly tell you what about the data? Remember what the residuals measure. And measure the actual minus the estimated. So if my residual is 0 exactly, what does that mean? No, not that there's no oranges. Because in this one, there's 6 oranges. So when x is 6, we have the best residual. But residuals close to 0 indicate that the actual and estimated values are almost identical. Almost identical are identical. If it does equal 0 exactly. Is it about this? Okay, so later. So yeah, residuals close to zero indicate that the actual and estimated values are really close. Wouldn't you say though that even though that one's like the best one, wouldn't you say that all these residuals are close to zero? Yeah, I've seen residuals of like 100. Okay, that would, if it's way far from zero, that means that that linear model is probably not the best linear model. When we use technology, it's gonna give us the best one. But sometimes they have like options to pick from. You want the one that has residuals closest to zero. Okay, so that kind of answers number 5. So number 5, you would say the 0.6, comma 1.617 has a residual closest to zero. And what that means about the weight of the box with that many oranges in it, that is close to the estimate, something like that. You can summarize the steps for how to use graphing technology yourself. I've shown you a few times. I put a lot of videos in Schoology, but if you need help, make sure you ask before to win or test. But the last part, the cool down, that's basically what you'll be asked on a test. So let's look at the cool down now. You had 2 out of 4 options. And these are all residual plots. So notice that each of these graphs of residuals, they're not giving us our actual data or our linear model. They're giving us the residual plots. But all of these are from the same set of data. What's different is the line of fits that they use. So which graph is most likely to represent the residuals from the best fit line? Talk about that briefly with your group, come to an agreement. So we're going to take a little vote here in about a minute. So then choosing between 4 residual plots, can you choose the one that would indicate the best line of fit? Okay, raise your hand if you think A. Raise your hand if you think B. Raise your hand if you think C. Raise your hand if you think D. Okay, so let me add, I kind of told you, but maybe we just need to write it down so that we can remember it. But residuals that are close to what are the best? Good. So residuals close to zero. And the way that these are plotted, maybe let me show you in Desmos real quick for the other one. You can click on each of these. The way that these are plotted go like X, comma residual for the residual plot. And that's what the cool down is, residual plot. So yeah, here's all my residuals. And of course, the closer that they are to zero, the better. At the x-axis, all the y values are 0. So really, residuals close to 0, or in other words, close to the x-axis, when graphed, are best. So I would probably say B and C are a bit too away from that to say that these are for the best fit line. Does that make sense why it's not C or B? Okay, because they're too far from the x-axis. We know that residuals close to 0 are best. Now we're choosing between A and B. Notice the difference. When we have a line of best fit, where did we say it has to go through? Compared to the rest of the data? So now we're talking about this black line here through the green dots. A line of best fit goes through the middle of your data. So that means that you would have some residuals that are positive, some that are negative if it's for the best fit line. Which one shows that, A or B? With some positive residuals and some negative residuals. All right, raise your hand if you think A. Raise your hand if you think B. Okay, A is best. It has it close to the x-axis. And it has some residuals that are positive, some that are negative. So residuals close to the x-axis are the best. Residuals, I don't know how to describe it. Above and below x-axis are best. And I wouldn't say are best, so I'll just say are better. Because really best would be if they were all touching the x-axis and none of them were above or below. But you need to have some above and some below, because that would be that your data, that your line of best fit is going through the middle. If it was this one, that tells me that my line of best fit goes above all my data points, and that wouldn't be a best fit. Okay, so answer is A. You'll have a question just like this on your test. You want to pick the one that's close to the x-axis, has some above, some below. Questions, comments, concerns? Okay, so then 14 minutes to work on your 4 problems. There's no reason you can't get that done in class unless you're super confused. But you should also be asking questions. You should be shooting for 80% or higher on all your unit 3 topics. Hold on. Aaron, what did you want?